which was the Japan's attempt to land on the moon. And it was really, for me, really fascinating watching it and the computer just basically showing where it was, its trajectory and everything. And this is a Japanese robot. It successfully touched down on the moon. There are some problems, Renee, with its solar power system.
So it can't do the job that it was sent there to do.
Listen, it's called the Smart Lander for Investigating Moon, or SLIM. It was brilliant because it basically gently lowered itself onto the surface of the moon near an equatorial crater. The reason that this is important is because it makes it Japan actually only the 5th nation to land on Earth's natural satellite, after the US, the Soviet Union, China and India. But I watched it coming down, and the fact that they managed to do it within 100 metres shows the complete precision it managed to do it in. Now, as you would expect, there are problems with any mission, and for reasons not yet understood, the craft's solar cells will not generate electricity. But what then happens is the batteries will eventually discharge, and they are worried about the craft going silent. So they've turned off their heaters. They're pulling down the pictures that they have from the craft at the moment.
I mean, it is going to go silent, isn't it? It's just about how long.
No, I'm ever the optimist. I'm going to talk now to someone who knows more than you on this subject, Andrew Lound, who is a space expert. Good morning to you.
Good morning. Thank you for having me.
No, great to see you again. Did you enjoy it as much as I did?
Yes, it's always very exciting. The heart race is very, very fast on these things. It's a good cardiac workout when you're doing a space mission, I'll tell you that. And the fact that it was a soft landing, a successful soft landing, was very, very impressive. And as you correctly said, landing it in an area which was quite small, because usually you have a large area to target, and this was very, very precision landing. And actually, there's a lot of good data come from that alone. The fact that that system has actually worked. It's just a bit unfortunate at the moment that there's a problem with the solar panels.
So when I was watching it, just watching the graphics as it was descending, it descended and descended, and then it looked like a perfect touchdown. And then we waited and waited. I actually went to bed whilst they were still confirming whether it had actually landed successfully. It really was, I think, a moment of tension.
It is. It always is. It's often seen as, it's usually, depending where you're landing, it's usually 7 to 10 minutes of absolute fear and terror on any mission which is happening, which is really good. And that's the thing that builds you all up, because bearing in mind all the scientists and engineers sitting down on the ground, there's nothing they can do about it. All they can do is sit and wait. And they've got to hope that the onboard systems are working perfectly well to actually drop it down. And the thrusters have to work just right to actually cushion that landing. And if they fail in any shape or form, which we've seen with other probes, then it smashes into the surface and then you've lost everything. So the fact they got it to touch down safely was the exciting bit. It was successful in ejecting 2 rovers onto the surface.
Yes.
One of which could operate independently. So that should be actually operating okay, depending on how well the charge was on that particular little thing. But that could be working independently and doing its job, which it'll do for a couple of Earth days. So
I've said that basically for some reason these solar cells don't work. So they are trying to work out why that is. Is it because they're actually rotated the wrong way so they can't actually get power from the sun? Will they eventually start working again? They haven't given up on the possibility the solar cells will somehow reorientate themselves and be able to get power. And of course they're trying to turn off everything but the critical functions of that. How optimistic are you that it will be restored, and why did it go wrong, do we think?
We don't know. I mean, certainly where they've landed on the moon, they're in a position where the sun will be high in the sky, so they should be able to get a good flood of light and solar energy. So they should be okay regarding that level of orientation. It just depends really if something serious has gone wrong with the communication between generating electricity and getting it into the batteries, which could be the problem here. And that can be done for there's a load of things that could have gone wrong. Jolting of the system once it actually managed to land, although the data that's come through suggested that soft landing was actually quite good. But it could be one of a million things. There's lots of things they could do. Switching off things that you might not want to use in the immediate term is the good thing, because therefore you're saving energy. Those people saw the film Apollo 13, if they remember the startup procedure, switching things off that weren't necessary actually gains you a lot of power. So they'll be doing that. Heaters, because the sun's high in the sky at the moment over the moon where they've landed, well, that's not too bad, because there should be get natural warming from the sun itself. So yeah, I mean, you've got to be optimistic, because you can't give up on anything. You never give up until there's absolutely nothing left at all. And I'm sure the Japanese, with their technical know-how, will be working as hard as they can, and they'll be able to get the science out of it while it is still there. While there's power, you will get science from it. So it's not going to be a wasted mission. It's just that, if you might say, it's not going to be as long a mission as they hope for, but you will get a lot of good science and a good engineering from it anyway.
And the fact that it was such a precision landing, I think, is a massive success for Japan.
Yeah, that bodes well for future missions. And you've got to remember that when you're doing missions like this, so it's the first time for Japan to actually successfully soft land something onto the moon, this is the test. This is to see if that systems work. And what you do is very much like Elon Musk when he's launching his rockets. You see what fails, you put that right, do the next one, see what fails, put that right, and eventually it all comes together. And that's exactly what happened with the Apollo program throughout the 60s, when they were using robotic rovers and then human landing. You actually do this step-by-step approach. And then once you've got it right, that's it. You know you're going to work with it. And that's the beauty of this one. It actually has been a success of getting the soft system landing. It just seems a real shame that one of the things that have failed is something that normally you would expect to have worked quite well. It's,
well, the devil's in the detail, isn't it?
Yeah.
It often is. But also, just in terms of that, you said the sun is still high in the sky, but obviously when the sun disappears, the temperatures plummet, and that will then could have a devastating impact on the electronics on the circuitry.
Yes. Oh, that's it, yes. I mean, these vehicles are only due to last a couple of Earth weeks, which is one lunar day. So therefore, yes, the temperature falls, battery power drains. Everybody knows that from their own equipment themselves. Once the temperature falls, battery power drains. And it's unlikely, therefore, especially if the heaters are off, you won't be able then to power the systems back up again. And therefore, yes, you have a dead spacecraft sitting on the surface of the moon, unfortunately.
Finally, I think there's something quite interesting about this, because the fact Japan has been able to do it, a relatively small country, when you look at China, for example, or the US, I think that shows the speed of development of this, and also Japan playing a role in the Artemis program with the United States.
Yes, it is. I mean, many small countries now, thanks to technological developments, can actually have space missions now. And getting into space with rocket launches using a whole variety of launches from various private companies as well has meant it's cost-effective now to get vehicles into space. And technology, even some off-the-shelf technology, you're able to put into this. Bearing in mind the cost of this lander was about $120 million. Bear that in mind to what it would have cost 40 years ago, where you would have been looking in the many hundreds of millions of dollars, and that's simply because the technology is more easily available. And I always joke about things like HS2, how much that is costing. We could actually fund a mission to Mars with that kind of money, which is quite when you think about it, that's a train, that's a set of trains and engineering, civil engineering works. What that is costing, and what then people can actually do with other technologies, it's quite an eye opener, really. It's cheaper to actually go to the moon.
Amazing, amazing stuff, Andrew. Thank you so much. Really good to talk to you. That's Andrew Lound, space expert.